सो आज हम पढ़ेंगे पेपर क्रोमेटोग्राफी और थिन लेयर क्रोमेटोग्राफी के कंपैरेटिव स्टडी। पहले हम लोग पेपर क्रोमेटोग्राफी से स्टार्ट करते हैं। मेन थिंग कि पेपर क्रोमेटोग्राफी किस लिए यूज होती है। पेपर क्रोमेटोग्राफी इज यूज्ड फॉर डिटेक्शन एंड सेपरेशन ऑफ अमाइनो एसिड्स। एक चीज आपको इन दोनों में सबसे पहले याद रखनी है that the mobile phase and stationary phase, there are two phases. In paper chromatography, the stationary phase is paper, and in thin layer chromatography, the stationary phase changes and it would be a thin layer of absorbent, that is mainly silica gel, alumina or cellulose on the substrate. Before going in the detail, I would like to tell you that this is paper chromatography and this is for thin layer chromatography. So let's just discuss the principle of the paper chromatography. So we are dealing with the liquid chromatography. So that is a type of partition chromatography. So in paper chromatography, the stationary phase is made up of paper, that is made up of cellulose fiber, which I already discussed. And here the stationary phase is silica gel, okay, that is made up, that we'll discuss later on. So let's just discuss the principle. So first of all, the stationary phase, first stationary phase is liquid water, and second is this one, that is moving solvent, that is mobile phase. So this is a solvent tank. The mixture of components which needs to be separate and migrate at different rates are placed on an average 2 mm from this bottom of the paper. That would be a sample. So indirectly we can say that the sample is placed between two phases. One is stationary liquid water phase and another one is moving water or moving solvent phase, that is mobile phase. So this is a principle of the paper chromatography. If I've told you that this is for liquid chromatography, if you wanted to use solid instead of liquid phase, stationary phase, then it would be an absorption criteria box over there, and the stationary phase would be changed with a resin coated. Okay, so let's discuss the principle of the thin layer chromatography. So here the silica gel is used as in stationary phase. So first of all, you have to remember that a silicon dioxide, that is the oxygen is connected to the two atoms of silica. Here for the silica surface, the OH attaches to the silicon dioxide and it will make a giant structure, that is SiOH. This silica surface is basically polar in nature, and since it's polar, it will create an hydrogen bond, van der Waals force or dipole attraction force. Instead of silica gel, one can use the alumina also. So aluminum dioxide and alumina surface, same as the silica gel, the principle is used. So this is the structure of the silica surface. So let's quickly go to the requirements. So solvent is required, sample chromatographic paper, since it is paper chromatography, airtight cylindrical jar, and in case of thin layer chromatography, the solvent, sample, silica surface, and airtight cylinder jar, and or you can say chamber. So now let's discuss the procedure. So as I've told, for the paper chromatography, paper is used. The small quantity of sample is applied almost at a 2 centimeter or you can say 1 centimeter away from the bottom surface of the paper with the help of a micro pipette or capillary tube. This procedure is known as a loading of sample, and it is done before we dip the paper in the solvent. Now that the sealed tank is filled with the solvent, so now the area of the paper, this which area which is dipped, the one thing you have to remember that you don't have to let the sample be dipped in the solvent. So the area of the our stationary surface, that is the paper, which is dipped in the solvent, that is known as developing solvent. Okay, and at the end there would be a development of chromatogram. For thin layer chromatography, there is a preparation of thin layer. It is available at the market too, and at the lab scale these are prepared. So you have to use a glass slide, plastic plate or a foil plate. They should be clean, dry and even. The surface shouldn't be uneven. So thick suspension will be making of H2O plus silica gel that would create a slurry in this plate slides. So suppose we have taken that. So we have to spread it uniform, thin layer on surface, let that dry. Then we have to heat it at 130 degrees Celsius and cool it at a room temperature. Now the loading of the sample and the development of chromatogram, this would be similar as of paper chromatography. The only difference was in case of the stationary phase, instead of paper we are using the silica surface. So let's quickly summarize this, that we have to apply the sample, a drop of a sample, okay, and then we have to dip it in the solvent which is in the jar, then the developing solvent as I mentioned earlier only. Then we have to wait for the development of the chromatograph. Then we'll observe spots on the plate, and this would will give us the result of our thin layer chromatography. So now after the development of the spots and that on the paper or either on the thin layer, there are certain things which is needed for the observation of the chromatogram. So that should be solvent front after dry, after the paper gets dried, will be marking the solvent front. Then we have to measure the solvent front from original, that we'll discuss later. But before that, in case of some chromatographic substances, we need certain reagents for visualization of certain bands. So for example, for amino acid, neem hydrine is used. So there's one term over here, that is RF value. So this is a migration parameter related to the migration of the spots. So migration parameter is basically the distance solvent front from origin to the distance of solute front from the origin. Okay, so certain factors I have mentioned here that are affecting the RF value, that is solvent, nature of mixture, medium used for separation, temperature, size of jar and container. So in case of thin layer chromatography, it is the same, that the solvent front is marked after drying and all that. For solute visualization, suppose in the case of sulfuric acid and nitric acid, the organic solvent, in short, we are using a heat and oxidation, and the brown and black spots are observed. In case of a chromatogenic reagent, colored spots are observed, and that is of amino acid by application of ninhydrin. Another one is UV lamp view, that is dark or fluorescent spots. Another one is vapor iodine. So in case of that, dark and brown spots are used, and after that the RF evolution is done. So here are the some applications I have mentioned. So for paper chromatography in industries, then in identification of any crime scene, then chemists would track the process, drugs of narcotics, that you can read from here. In case of thin layer, these are the advantages like checking purity, large scale, then qualitative analysis. Here I have mentioned the advantage and disadvantage of the thin layer chromatography, that you can read it off. It's not that much necessary. So let's quickly summarize about the types of paper chromatography. Yes, so paper chromatography is having our ascending as well as descending paper chromatography type. So this is ascending chromatography, this is descending chromatography. Another one is circular chromatography and ascending descending chromatography. So in case of ascending chromatography, the solvent to move the paper upward and the gravity does not support this. In case of descending chromatography, the solvent to move down the paper, and here the gravity, this is under the influence of the gravity. So you can observe it. And by the figure you can understand the concept. So basically the definitions and the basic concept is important for the types of paper chromatography, and that is about the paper chromatography and thin layer chromatography, a comparative account. The notes I've provided. So thank you so much.